Okay, today we're talking about the metric system. This is part 3 of the pre-physics unit. So we're talking about the metric system, or what's known as the International System of Units. It's used in almost every part of the world except the United States, and is the major system in science, even in the United States. Its conversions are based on powers of 10, which is why science prefers it, and it's not cumbersome numbers like 12, 16, or 5,280. There are 3 main types of measure used in any system: length, mass, and volume. Each of these types of measurement has a basic unit of measure in the metric system, and multiples of that unit, which are formed by adding prefixes. So the basic unit of length is the meter. This is originally defined as 1/10 millionth of the distance to the North Pole. Distance, and we'll say that's equator to North Pole. 1/10 millionth, so that is 0.0000001. Or a little easier, 10 to the negative 7. It is now defined a little differently with technology improving. 1 meter equals here we go. 1 meter equals this number of wavelengths of the 86 krypton isotope light. So they have a pure sample of 86 krypton, or krypton 86, and they run electric current through it, and it creates light. And this particular light has this many wavelengths. For mass, we have the gram. Volume is the liter. There is a list of prefixes on page 17 of your book. If you don't have the book in front of you, Google is a powerful tool. It will tell you all of the metric prefixes. It'll give you a table, so take a look there. But if you have your book with you, it's on page 17. So looking at page 17, some examples of a prefix with a basic unit. So here is nanometer. Nanometers are fairly common. You would hear about this maybe with nanotechnology, or maybe in terms of the wavelength of light. A nanometer, that is 10 to the negative 9 meters. A centimeter, looking at the table, find 10 to the negative 7 meters. Kilometer, looking at the prefix, kilometer, K, that's 10 to the third power meters. Most common units used in this course: the kilogram, that is 10 to the third grams. The kilometer, 10 to the third meters. Centimeters are another possibility. that is 1/10 meters. Some practice changing metric units. 5.2 meters becoming centimeters. Look at this relationship. In 1 meter, there is 100 centimeters. So 5.2 times 100, that is 520 centimeters. 1.45 kilometers, how many meters? A kilometer is 10 to the third meters. So you have 1,450. Centimeters, 3.7 centimeters is how many meters? Now, think about this. A centimeter is 1/100th of a meter. So it should be in the 100th place in terms of meters. So moving the decimal to the left 2 places, 0.37 meters. This is your 1/100th of a meter. 8,200 meters, what is it in kilometers? This is times 10 to the third, 8.2 kilometers. A meter is smaller. 1,000 of them makes 1 kilometer. 8.2 kilometers, 8,200 meters. Centimeters to kilometers. This type of conversion can be a little bit more tricky. So you want to be careful that you do it correctly. So what we're going to do is set up calculation here. 7.5 centimeters, and we're going to do some conversions. So let's say in 1 meter we have 100 centimeters. And in 1 kilometer, because we want to know kilometers, there are 1,000 meters. And if you look at your units, if you line them up correctly, centimeters on top cancels centimeters on bottom. Meters on top cancels meters on bottom. And we're left with units of kilometers. And so our answer here is 7.5 times 10 to the minus 4th power. Other side, 7.3 times 10 to the 8th centimeters. We want it in terms of meters. There are 100 centimeters in a meter. So in terms of meters, the number should be smaller. In terms of centimeters, the number is larger. .3 times 10 to the 6th power. Here's really what we did here, in case anyone is becoming lost. We had 7.3 times 10 to the 8th, and centimeters, which are 10 to the negative second. And this goes back to that scientific notation thing that we did on day 1 of the pre-physics unit, where these have the same base, and so we add the exponents. 8 plus negative 2 is 6. .3 times 10 to the minus 4 meters. So that's a fraction of a meter. What is it in kilometers? It's going to be a very, very small fraction of a kilometer. So this is times 10 to the minus 4th meters, and we end up with very small number in terms of kilometers. 8.9 times 10 to the 7th grams in terms of kilograms. 8.9 times 10 to the 4th. There are 1,000 grams of kilogram. So this number is 1,000 times smaller than this one. 2.78 times 10 to the 7th milliliters. Milliliters, that should be a capital L. That should be liters. A milliliter is 1/1000th of a liter. So the number for liters should be 1,000 times smaller, which is 2.78 times 10 to the 4th power. Last one, 9.8 times 10 to the negative 2 kilograms. (9.8 grams). If you were to put this in standard notation, 0.098, this is where the grams would be 98 grams.